channel Maths and Methods Academy. In this video, we are going to learn how to find LCM of the given algebraic expressions by factorization method. The expression given in this question, the expressions given in this question are, we have two expressions in our first question, which are x squared minus 25x plus 100. This is our first expression, and the second one is x squared minus x minus 20 . Okay, now please remember to subscribe the channel, and now we proceed with the solution. Let us give some name to these expression. So let px is equal to x squared minus 2x plus 100 and qx is equal to x squared minus x minus 20. Now we will factorize these expressions one by one. So let us take the first one first. We have px is equal to x squared minus 25x plus 100. Since this is a quadratic expression, so okay, it is a quadratic expression, but we have a condition here that we have to solve it with the help of the factorization. So let's go for the factorization. Since x square is not having any coefficient, it means its coefficient is 1, and we will multiply it with 100. So what we will get out of it? 1 into 100 is equal to 100. Now we will write all the possible pair of factors that when we multiply give us 100, and when we add or subtract them it gives us minus 25. So let us start. The first one will be the same, which is 1 into 100. Second is 2 into 50. Third is 4 into 25. And the fourth is 5 into 20. So these are the four possible pair of factors. Now we have to choose one out of these, which will give us if there either their sum should give us this 25 or their difference should give us this 25 minus 25 actually. So obviously this one is the pair of factor which is fulfilling this condition. So instead of minus 25x, we can break it down into two, that is 5 and 20. So we will write minus 20x minus 5x so now instead of minus 25x we will write minus 20x minus 5x plus 100. Now we have four terms, and we will be taking common in the first two and in the last two. In the first two we have common x, and we are left with x minus 20 in the bracket, and in the second one we have minus 5 common, and in the bracket we are left with x minus 20. Now in both the terms we have x minus 20 common, and in the second bracket we are left with x minus 5. So this is our first expression. This is the factorization of our first expression. Let us call it number 1. Now we move on to our second expression. Second expression is qx is equal to x squared minus x minus 20. Again here x squared has no coefficient, which means it is 1. Now we multiply this 1 with minus this 20. For the time being we will ignore minus, there is no need of that. Now we have got 20, so we will make all the possible pair of factors for this. The first one is 1 into 20 is equal to 20. Second is 2 into 10 is equal to 20, and then 4 into 5 is equal to 20. Now we have to select that pair of factor out of these three, where either their sum will give us minus 1. Here again its coefficient is 1, minus 1, or their difference will give us minus 1. So obviously the last one is fulfilling the condition, where we can write minus x is equal to minus 5x plus 4x. So this minus x will be replaced with minus 5x and plus 4x. Let's remove our rough work. So we remove the rough work. Okay, so we will replace minus x with minus 5x plus 4x minus 20. Okay, in the first two terms x is common, so within the bracket is left x minus 5, and in the second two terms we have plus 4 common, and we are left with x minus 20. Sorry, x minus 5, not 20, because 4 we have taken common, so 4 into 5 will be 20. X minus 5. So now we have x minus 5 common in both the terms, and the second bracket will come out to be x plus 4. So now we have factorization of second expression also. Now how we will write the LCM here? Actually we have to take, if you have gone through the sets, we have here two expressions in the, two factors in the first expression, and we have two factors in the second expression. What we have to do, actually we have to write a union of these factors. First of all we will write that one which is repeating in both, which is x minus 5. So this one we will be writing only once. Now left behind are two more factors, where one is in equation number 1, which is x minus 20, and the other one is in the equation 2, which is x plus 4. So these one we will write one by one. X minus 20, and from the second expression we will be writing x plus 4. So in both the expression we were having 4 factors, but in LCM we are writing only 3, because the common one we have taken only once. So what we have written now, LCM is equal to x minus 5 into x minus 20 into x plus 4. So this is the LCM and answer to this question. Now we move on to our second question. Our second question has actually 3 expressions, so we will write them one by one. The first one is x squared plus 4x plus 4. Second one is x squared minus 4, and the third one is 2x squared plus x minus 6. So these are the three expressions. Now first of all we will give them a name. So we assume that let px is equal to x squared plus 4x plus 4, qx is equal to x squared minus 4, and rx is equal to 2x squared plus x minus 6. Okay, now we will move on with the factorization. Like we will go for the first one first. So our first expression is px is equal to x squared plus 4x plus 4. Again, since we have to factorize it, so we have to look for the coefficient of x square, which is not there, which means it is 1. Now we will multiply 1 with 4, so we will be getting in that way 4. 1 into 4 is equal to 4. Now we will be writing all the possible pair of factors of 4. The first one is the same, which is 1 into 4 is equal to 4, and the second one is 2 into 2 is equal to 4. Now we have to choose one out of these two, sum of which will give us 4 or difference of which will give us 4. So obviously we have this pair of factors which is fulfilling the condition, that is if we add 2 and 2 we are getting plus 4. So we will be replacing 4x with 2x plus 2x. Okay, let us replace 4x with 2x plus 2x. Now in the first two terms x is common, and in the second two terms 2 is common. Now in both the terms x plus 2 is common, and in the bracket also we are getting x plus 2. So this is our factorization of the first expression, which is px. Now we go to the second one, which is qx is equal to x squared minus 4. In this expression both the terms are complete square and there is a minus sign in between. So in these types of situations, what we will be doing, we will be using this formula: a squared minus b squared is equal to a plus b into a minus b. So here we will be writing x plus 2 into x minus 2. So this is our second factorization. But in this question we have a third one as well, which is rx is equal to 2x squared plus x minus 6. Now for the sake of factorization we have to multiply this coefficient of x square with this 6. What we will get in this case, it is 12, so 2 into 6 is equal to 12. Now we will be making all the pair of factors of 12. The first one is 1 into 12 is equal to 12. Second is 2 into 6 is equal to 12, and the third is 3 into 4 is equal to 12. Now we have to choose one of these pair of factors where the sum of both the factors should be equal to x, or the difference of both the factors should be equal to x. X means 1 here, because here we have one coefficient only in this term, because there is no particular coefficient like 2, 3, 6 anything is mentioned. So when nothing is mentioned, it is 1. So the last one is fulfilling our condition, where instead of, which we can write like, instead of x, this x, we can write 4x minus 3x. Now we remove our rough work. Okay, 2x squared, instead of plus x we will write plus 4x minus 3x and minus 6. Now in the first two terms 2x is common, so we are left with x plus 2, and in the second one we have minus 3 common, so we are left with x plus 2. Now again in both the terms x plus 2 is common, and in the bracket we have 2x minus 3. So now we have 3 factorizations, 1, 2 and 3, which is mentioned here. Again we have to do the same thing. We have to take union of these factorization. First of all, let us find the common factors. Here in this case we have x plus 2, x plus 2 and x plus 2 is there in all the 3. Right? First we will write this x plus 2, LCM is equal to x plus 2. Now we will gather all the remaining factors from all the 3 factorizations. So in the first one, what we are left with, it is x plus 2. In the second one we are left with x minus 2, which is this one, and in the third one we are left with 2x minus 3. Okay, here we can slightly simplify, because x plus 2 is appearing twice, so we can write square of x plus 2, then x minus 2, and then 2x minus 3. So this is our required answer of this second question. Now we will move on to our third question. Third one, the first pair is 2 into x raised to power 4 minus y raised to power 4, and our second expression is 3 into x cubed plus 2x squared y minus xy squared minus 2y raised to power 3. Again we will name these two expressions. So let px is equal to 2 into x raised to power 4 minus y raised to power 4, and the second one qx is equal to 3 into x cubed plus 2x squared y minus xy squared minus 2y cubed, bracket close. Let us start with the first one. We will go for the factorization. In this expression we can see that both the given terms in the bracket, they are complete square, and there is a minus sign in between, so we can write it like 2 into x2 raised to power 2 minus y2 raised to power 2. This is the shape of the formula which we are generally writing like a squared plus b squared is equal to a plus b into a minus b. So using this formula we can factorize it. So we will get 2 into x squared plus y squared and then x squared minus y squared. Okay, the second bracket is again, it is the same situation, like we are having two squares and there is a minus sign in between. So we will apply this same formula here. We will write like x squared minus y squared so we can break it down into x plus y into x minus y. So this is the factorization of our first expression. Now we move on to our second expression. Qx is equal to 3 into x cubed plus 2x squared y minus xy squared minus 2y3. We have to play a small trick here in this expression to factorize it. What we will do, we will break this minus 2y cubed into minus y cubed and minus y cubed, and we will write it like, we will bring 1y cubed here with y3 x3. So we are here now with x cubed minus y cubed, and the remaining expression we will write as it is, 2x squared y minus xy squared, and out of this 2y cubed we have already taken 1 minus y cube here, so we are left with only 1y cubed here. Now the first two terms are these two terms, both are perfect cube, so we can write it like x raised to power 3 minus y raised to power 3, and in the next three terms we have y common, so we are left with 2x squared minus xy minus y squared. Now these two terms are similar to a formula which is a cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. Now we will apply it here. So we will be having x minus y into x squared plus xy plus y squared. Now the last three terms, which are in the bracket, we will be breaking down the middle term as minus 2xy plus xy minus y squared. Now in the first two terms we have 2x common. We are left with x minus y, and in the second one we have plus y common, and we are left with x minus y. Okay, now here we have x minus y common, and in the bracket we are left with 2x plus y. This bracket is no longer required. Okay, now we have two expressions. First is this one, second one is this one. You can see that x minus y is common here. So we will take it out, x minus y, and inside the bracket we are left with x squared plus xy plus y squared plus y into 2x plus y. Right? Now we will simplify inside the bracket. How we will do it? We will open all the brackets. So we are left, we will be having x squared plus xy plus y squared plus 2xy plus again y squared. So x squared, this xy will add to this one, it will come plus 3xy, and this y square and y square will add, it will be 2y squared. This expression in second bracket is further factorizable. And how we will factorize it? The same way, what is the coefficient of x squared? It is 1. Coefficient of y square is 2. So we will multiply these two, and we will be getting 1 into 2 is equal to 2. So in this case we have only one pair of factor, and we have to see if we can get 3 by adding or subtracting these two, 2 and 1. Yes, if we add 1 and 2, this 1 and 2, we will be getting 3. So instead of 3xy, we can write 2xy plus xy. Okay, now instead of 3xy we will be writing 2xy plus xy plus 2y squared. Now 3 into x minus y. Here in the first two terms we have x common, so we are left with x plus 2y, and in the second one we have y common, and again we are left with x plus 2y. So when we take x plus 2y common, we are left with x plus y. So this is the factorization of our second expression. Now we have to write the LCM. Okay, in the first expression, do we have anything common in both? Yes, we have this term and this term also there, x minus y and x plus y. So these are common terms. We will write first x minus y into x plus y. Now the terms which are left in both the expressions, here it is x plus 2y, this one, and we will check if any term is there in the first expression also. Yes, there we have 2x squared plus y squared, x squared plus y squared, and in both the terms, in the first one we have 2, and in the second one we have 3. Okay, let us simplify it. 2 multiplied by 3 is 6. When we multiply x minus y with x plus y, we will be getting, it is again form of a formula, which is when we write x squared minus y squared. Which formula it is? It is a minus b into a plus b is equal to a squared minus b squared. So similarly we have written here x squared minus y squared. Then we have x plus 2y into x squared plus y squared. We will slightly rearrange it also. 6 x squared minus y squared into x squared plus y squared into x plus 2y. Again we will apply the same formula over here and we will gather them. It will become 6 into square of x2 minus square of y2 . So our final answer is 6 x4 minus y4 into x plus 2y, which is the LCM of this question and the answer as well. So we have completed our 3 questions. Now we have fourth one. In fourth one, again we have only 2 expressions. The first one is 4 into x raised to power 4 minus 1, and the second one is 6 into x cubed minus x squared minus x plus 1. So like the first 3 questions, we will give some name to these expressions. So let first one is equal to px and the second one is equal to qx. Now we will factorize the first one first. In the bracket we have both complete squares, so we can write them like and this we can factorize with the help of this formula. A squared minus b squared is equal to a plus b into a minus b. So let us break it down like this. 4 into x squared plus 1 into x squared minus 1. Now in the second case we again have the same situation, so we will write like x squared plus 1 x squared minus 1 squared x squared plus 1 into x plus 1 into x minus 1. So this is our factorization of the first expression. Okay, now we move on to our second expression, which is qx is equal to 6 into x cubed minus x squared minus x plus 1. We have 4 terms inside the bracket. The first 2 terms will take x squared common, and in the second 2 terms we will take minus 1 common. So let's do it. So it is 6 into x minus 1 into x squared minus 1. This x squared minus 1, again we will factorize the way we did this one. So we will write it 6 into x minus 1 square of x minus square of 1 6 into x minus 1 into x minus 1 into x plus 1, and this is our second expression. We forgot to factorize the digits. Instead of 4, we will be writing 2 into 2, and here instead of 6 we will be writing 2 into 3. Okay, now we will write the LCM, and we will follow the same rule. First we will write the common factors. What are the common factors? 2 is common, then x plus 1 is common, and x minus 1 is common. So we are writing 2, then we are writing 3. After that we are writing, what are the common? X minus 1 and x plus 1, these are common. And after that we will be writing which are left out. Okay, so 2 into 3, x minus 1 into x plus 1. Now what is left there? This x square plus 2 is left in the first one, and x minus 1 is left in the second one, and one digit is left here, which is 2. We have to bring it here. Now we simplify it. 2 into 3 into 2 is 12. Then these two factors are of this formula shape, like a minus b into a plus b is equal to a squared minus b squared. So we will apply it here. X squared minus 1 squared so 12 into x squared minus 1, and here x squared plus 1, and then x minus 1. Again we have the similar situation here, and we will apply the same formula. 12 into square of x square minus square of 1 into x minus 1. So we are having our final answer as 12 into x4 minus 1 into x minus 1. So this is the LCM of this question and answer as well. Now we move on to our last question of this series. In our last question we have first expression as 20 into 2x cubed plus 3x squared minus 2x. This is our first expression, and the second expression is 9 into 5x raised to power 4 plus 40x. So this is our second expression. Like always, we will first name them. So let px is equal to this one and qx is equal to this one. So we will go for the factorization of the first one first. Okay, the expression in the bracket has 3 terms, and all the 3 terms have x common in them. So we will take it common, 20x into 2x squared plus 3x minus 2. Now inside the bracket we have a quadratic expression and we will try to factorize it now. So let's multiply these two. 2 into 2 is equal to 4. We'll write down all possible pair of factors here, which are 1 into 4 is equal to 4, 2 into 2 is equal to 4. So which one is satisfying? Which one, if we consider, should either its sum should give us 3 or its difference should give us 3. So the first pair is fulfilling that condition, because when we subtract 1 from 4 we are getting this 3, this 3. So instead of 3x we can write 4x minus x. Let's write it down. 2x squared plus 4x minus x minus 2. Now in the first two terms inside the bracket we have 2x common, and we are left with x plus 2. And in the second one we have minus 1 common, so we are again left with x plus 2. So we will take x plus 2 common, and the second bracket will come out to be 2x minus 1. So this is the factorization of our first expression. Now we go towards our second one, which is 9 into 5x4 plus 40x. The two terms which are in the bracket, they have 5x common in them, so we will take out 5x, and inside we are left with x cubed plus 8 so we will be writing it like now 3 into 3 into 5 into x, and here we will be factorizing again x cubed plus cube of 2. Here we have to apply formula a plus b cube, a cube plus b cube is equal to a plus b into a squared minus ab plus b squared. Let's apply this. 3 into 3 into 5 into x plus 2 into x squared minus 2x plus 4. And one more thing, in case of first one we forgot to factorize the digit which is 20. We will be factorizing it also. It will be 2 into 2 into 5 which is 20, then x left, x plus 2 and 2x minus 1. So this is our first factorization. Okay, now we will write our LCM. First we will select the common factors. In the first one and second one 5 is common, so we are writing 5. Then check for the other digits also. We don't have any common digits, so we will write all the digits like 2 times 2 and 2 times 3. Now we go toward the expressions. What are the common expressions? Like x is common, so we will write x. Then x plus 2 is common, so we will write x plus 2. X plus 2 and what is left now? 2x minus 1 is there only in the first one, which we will write, and then x squared minus 2x plus 4 is there. Now let us simplify it. Five multiplied by 2 is 10. 10 into 2 20. 20 into 3 60. 60 into 3 180. Then we have a x. Then we will write x plus 2, 2x minus 1, x squared minus 2x plus 4. So this is the LCM of this question and the answer as well. That's all for now. Until the next time, please take care and bye.